I just wanted to ask that if these Zoom recordings are recorded and
Yeah.
put somewhere.
Yeah, so they're all on
website.
my yeah. So yeah. Yeah, one file.
I can just stick all the functions into one.
That's right. All right. Hi everyone. Hello. Hello, hello. So a few kind of hi. So a few housekeeping notes, and then we'll move on to the material. If you have questions, please post them on Piazza. Relatedly, please check Piazza. So when I post an announcement, there is a checkbox that says override users' preferences and send the email anyway, even if you didn't want it to be an email. I always do it. So you can rely on that. However, it doesn't help if you just ignore all my emails, which a lot of people do in my personal life as well. But you shouldn't. So please make sure that you either get all the emails from Piazza and actually read them, or that you read Piazza regularly because there is important stuff there. So specifically, as far as important stuff, so there was an announcement about the first online assignment. So the second online assignment is going to be basically the rest of the coding math exercises. So if you want to get started on them, you absolutely can. It's just that we don't have the material for anything that's not there. It's like not a few exercises, but a lot of them are not very difficult, right? So the warm-up ones are really kind of should at least be a couple minutes, and then list 2 is kind of the exercises that are like maybe more similar to what you have at the lab level, but there are just 6 of them. So those are to be submitted on Gradescope, and this is 1%. So the way coding math works is you can enter the Python code in there, and it'll tell you if you're correct or not. It's going to run its test cases. So what I actually recommend doing is, So what I recommend doing is actually doing it in Paizo rather than on the web browser, just because it's much easier to debug if you are tracing in Paizo. So one thing that I find happens a lot is people, just because it's easier to put something in the web form, or it's easier to just try to fix your code in whatever way you think would work, people just do it instead of tracing, and that's actually slower. So there is a pejorative term for that in kind of programming culture. It's a little bit violent. It's called shotgun debugging. So the idea is you have a program, it doesn't work. You just kind of stare at it. You say, oh, I know what's the problem. You're probably wrong about that. And then you try to fix it, and then it still doesn't work. And then you just repeat until it's fixed, or until you're too tired and you just procrastinate until the next day. So don't do it. Trace. I think people working on project 1, I think most people saw the value of tracing early on this semester, I hope. So I hope that you keep learning from that. So shotgun debugging, again, kind of just like, how should I say it? So not exactly randomly, but non-systematically trying to fix code and trying to rerun the code to see if it passes the test or something. So one thing that, just because of the nature of the class, it's a very large class with 300 people, we kind of made the decision to give you all the tests, or almost all the tests for project 1. And that kind of encourages people, I think, to do shotgun debugging, because, well, you have all the tests, And then you know that if you pass the test, then the program works. So it's kind of very tempting to just fix things a little bit and then try to run it. And then the headache is gone if you happen to fix it. That's not how things usually, well, I shouldn't say, like a lot of professional programmers work like that as well, but they're not the good kind of professional programmers. So it's much better to do things systematically. It's just in the long term, and by long term, I mean kind of not very long. Like it's like better to do it for you psychologically, maybe for the 30 seconds where you hope that things are going to work out. But then like on second 31, you're going to be disappointed because usually it doesn't work out. So it's better to trace, even if your horizon of like thinking about the future is like 5 minutes, probably it's better to do things systematically. So you might know about the study that was discredited, I think, at this point. I don't think it's actually like true, but they like put children in a room and they left a cookie on the table. And they said, the experimenter says, I'm going to leave the room. And if you don't eat the cookie when I come back, then I'll give you 10 cookies. But if you do eat the cookie, then I'm not going to give you anything. And then some children ate the cookie and some children didn't. And then supposedly, I think it was kind of discredited, but supposedly like the life outcomes for the children who did not eat the cookie were better than for the ones who did. I don't think it's like literally true study at this point. I don't think it's considered to be true, but I think the lesson here makes sense. Like it makes sense to think a little bit long term, and it'll lead to better life outcomes for you. So I was saying, so coding back, so it's worth 1%. So it's kind of like nothing. It's more like practice for the midterm. So I would say that someone who's like completely ready for the midterm would have probably no problem at all with any of the exercises apart from list two. List two are, somewhat difficult. So at this point, I think on Monday, you'll be able to look at past midterms. They're already there on the course website, but not all the questions are going to make sense. By Monday, you should have a pretty good idea of what the midterm will look like. I'll mark out the questions on the past midterms that you still cannot do by Monday, and you can begin kind of looking at the midterm. I suggest that maybe next week you do one practice midterm just to see what it's like writing code on paper. It's a little bit different from writing code on a computer. So the coding math exercises, I realize they're like, it's not like a few, but in my estimation, which might be wrong, it's probably not very much time if you're already ready for the midterm. If you're not, it could take a lot of time, but that's time well spent because you got to get ready for the midterm. So in past years, coding back was not mandatory. And I think that maybe was a mistake. So this year I'm trying to make it mandatory, albeit it's not worth a lot of points. And the point is really to give people an incentive to practice. This is also individual. So sometimes what we have in class is because the projects are partnered, not all the students have really experience with writing code by themselves. That's of course bad, and we try to make it so that in the labs everyone has the experience, but I think we miss some people. So that's also a way of making sure that everyone has written some code before the midterm. So that's the idea. And 1%, and it's not going to be like the assignment where it's kind of, if it's like a percentage of the tests that you pass, it's more like if you made a reasonable attempt, we'll give you full credit. With that, it's in your interest to make a more than reasonable attempt. So, okay, so that's that. And there's going to be an auto grader. It's just that we don't have one yet. Technical questions about the lecture. Again, I think like in the technical Q&A on Discord, we are mostly having fun, but questions go here. Otherwise, please post questions on Piazza as well, not during lecture. Okay, so one more thing that I wanted to show you, this is like not in the midterm, but I think it's kind of worth looking at, is the interaction with ChatGPT. So Like honestly, for most problems in ESC180, ChatGPT can just solve them anyway. Once you get to 190, it becomes a little bit more dicey. So the more complex things in 190, ChatGPT still cannot solve. So I'm still teaching you useful stuff. With that said, some things ChatGPT does so well that maybe there's no point to trying to do them using programming. So in particular, I thought about, okay, like I posted this code, this annoying code for testing for project one. And then if you wanted to trace it, one way to do it was to just extract the code and put it in the main block. And you can do something like that with ChatGPT, like really easily, right? So all I needed to do was to say, okay, here's one example of what I want. And I just put an arrow that's like made up notation. It's not really programming, but ChatGPT is more flexible than Python, right? So I said, like, if I give you this kind of thing, transform it to this kind of thing. So that's referred to as a prompt. I don't know how many people know about like prompt engineering? This kind of thing where you try to make ChatGPT solve the problem for you, and sometimes you got to think about it, like how do you ask it exactly, is referred to as prompt engineering. So prompt is the thing that you put into ChatGPT. ChatGPT then gives you the output. So here, the prompt engineering was just, I made up a notation. So I said like an arrow. And then I gave it an example of the kind of thing that I want. And then I just told it transform the following. And as you can see, it did, right? So with a lot of the more simple tasks that in the past you might have done with Python, something like ChatGPT, not necessarily ChatGPT, you can do Bard or whatever. You have to get a VPN for that though. So Bard is Google's competitor to ChatGPT. It's not available to Canada, thanks to the wisdom of our legislators who made the legal environment such that it didn't make sense for Google to have Bard in Canada. You can, however, make a get a VPN for very cheap or free and pretend that you're from America. It's all good. So here you see that it transformed this. So just because I think kind of not everyone has experience with this, I'm not sharing my screen, am I? So just because not everyone has experience, so there's two people on Zoom. So please tell me if something is wrong. I can't always tell, especially with Zoom and stuff. So you can do something like that. And kind of for a lot of things. So I'm going to try something live. I'm not sure. ChatGPT, of course, doesn't always give you the same response, but I think it's going to work. So I can ask it like, how many ANXI graduates alive are there? And my guess is it's probably going to refuse to respond. So let's see. Yes. So what it says is, okay, is it challenging and rigorous program? Yeah, great. You would need to reach out to specific institutions, alumni association. There is not even such a thing. The registrar's office is not going to tell you anything. So what can you do in order to get ChatGPT to cough up an answer? So one thing you might do, so you might just tell it like pretty please, and sometimes that works. Another thing you can do is you can frame the problem as something that you could answer. So something called a Fermi problem. So after the physicist Enrico Fermi is the kind of problem, by the way, also the kind of problem you might get in the job interview is a problem where you're asked to estimate some quantity, and the process is you're trying to plug in reasonable values, and you kind of guess at the values, and then you have a process of coming up with the answer. So what I'm going to try to do is I'm going to try to say same question, but treat it as a Fermi problem. And here it is. Well, not a good, well, a reasonable assumption, not true. So it's about 70 years, I believe. And here you see that it's gonna try to come up with an answer. So that kind of process is sometimes referred to as prompt engineering. So trying to get the kind of answer that you want, and sometimes you got to try several things, but a lot of the time it works. So 10,800, I think this is actually in the ballpark. I think it's a little bit fewer. I think it's like 7,000, but I did not look it up before lecture, sorry. But you can look it up. All right. So that's like that. So back to the technical content. So what I want to do today is keep talking about pseudo-random numbers and actually make something that looks like random.random. Sorry, can I get a little bit more quiet here? Epsilon 05. Epsilon 04. Epsilon 04, you're facing, I'm seeing your back and you're talking. Epsilon 04, guy in a jean jacket. Please stop talking. You don't know your Epsilon 04, do you? Okay, it's you. Please tell your guy. Yeah. Okay. All right. So to remind you, this was the process for getting pseudo-random numbers, right? So we had this idea of we start with X and then we keep transforming X. And the way we keep transforming X is multiplied by a large number, add another constant, and then do mod M. So basically the idea is if you make the number smaller so that it makes sense, let me just make this be like 13. So what happens? Well, the numbers kind of just jump around, right? So because it's mod 13, it's always going to be between 0 and 12. So, and you multiply by a huge number. So it looks like some kind of sequence of numbers between 0 and 12. In this case, they happen to go in a cycle, right? So it's like 12, 2, 4, 1. Well, if X is 1, you're done. Now you're going back to 12. All right. So if you do a very large number, then it's going to look like, well, a bunch of numbers and you just jump around there. So random.random gets numbers between 0 and 1. Well, that's not a problem. So X is a number between 0 and M minus 1. So if instead of X, we print X divided by M, that's going to look like a bunch of numbers between 0 and 1. And they're going to be approximately between 0 and 1. So they're not quite going to get to 1 because X is at most M minus 1 because mod M. But close enough. If M is very large, that means that you can get like 0.9999 and so on. All right. So that's like that. So now let's say that we want to actually make a function that does this. So we're actually going to use some tools that you had from project 1 in order to accomplish this. So what do we need? So this I'm going to comment out eventually. So I'll name the function random, like so. And what do we need from random? Well, we need to know what the previous X was, right? Because if you know what the previous X was, you can compute the new X and then compute X over M, which is your output. So this is similar to how you, for example, keep track of time when you are doing perform activity. You used to have the current time and now you perform the activity and now you have a new time. So in the same way, we got to update the X. So again, it makes sense for X to be global, right? So I'll just say global X. And I'll say X is now this much. And I'll say return X over M. So you also need this stuff, so I'll just copy it over. So I heard Discord is saying something. So do we need to pass all public tasks so we get to 0? So I assume you're talking about, I assume, so yeah, so if you don't pass the grade scope tests, then you probably won't get a high grade on project 1. So for coding bat, like I said, it's graded on kind of best effort. So if you pass all the tests on coding bat, you're good. We're not going to like test you on more tests than that. So, okay. The deadline is not 10 p.m. today. The deadline was, well, Friday, and then you have 3 more days. So, oh, actually, yeah, so 10:59 actually today. Yeah. Okay. All right, so I'm putting this stuff here. And then I'm updating x, and I'm saying return x divided by m. So that's my function, right? So I can now comment this out. And now I can say print random. Like this. And then if I do it twice, it's going to be like this. And so on. Right? And if I run it again, that's going to be like this. So we made basically our own pseudo-random function. So one thing that you might like to do is you might like to have numbers that look random, but you might like to have consistency across how you run your code. In order, for example, like if you submit some code and claim that it works and it uses random numbers, some algorithms inherently actually require randomness, and it's not known how to make things work without randomness. One example would be primality testing that's really efficient. It actually requires you to have a random number generator. It's not known how to make it work without that. So if you want for your program to be consistent across runs, what you might like to do is you might like to start from the same x. So that's known as the seed. So we already mentioned it a little bit. So the starting point of a sequence of pseudorandom numbers. So one way we can do it is we can say, okay, so we'll have a seed like this. And that would require some kind of input. So I'll name it like seed x. And here, again, we'll make x be global because we want for it to be the same x that random access is. And we'll just set x to seed x, like so. So what I can do now is I can say seed and then give it seed x, for example, 5. So what's going to happen now is every time I run the code, I'll get the same sequence of supposedly random numbers. Why is it the same sequence every time? Well, because I just set the x to 5, and then I do 5, get me the next x, get me the next x, get me the next x. Of course, it's going to be the same thing every time. So sometimes what you want to do is you want to make sure that actually the output is random every time. So for example, if you're like generating a random password or something, you really don't want for the random, supposedly random password to be the same every time. So an easy trick that people use is they say, I'm just going to use the time as the seed. So the time is different every time. So I'll just get it. And I'll put it as the seed. So in Python, you can import time. It's not literally importing the concept of time, it's just the library. And then you can say time.time. And this gives you the number of seconds since January 1st, 1970. That's just how it works. So this is how many. At midnight. So this is also known as epoch time. So the epoch would be kind of the epoch since kind of modern computers or something, I think the idea. All right, so that's a float, but that's okay. I'll just convert it to an integer and I can use seed for that. So I'll say seed time.time, and here I'll convert it to an integer like so. And if I do that, so print random.random. And the idea is that every time I run this stuff, not random.random, just random. So anytime I do this stuff, it's going to give me different random numbers. Why? Well, because the seed is different every time because the clock is ticking. Right? And that's usually good enough for most purposes if you want to get kind of random looking stuff. Okay, there's a lot of stuff that's not in the technical Q&A. I'm not, okay, let me see what people are saying. Fascinating. So that's on Piazza. There are links. Why do we need, so please ask in technical Q&A. This is not a nerd face kind of question. So why do we need a global X? So the answer is the reason we need a global X is we want to keep track of what the X was last time. And then next time you call random, you update that X. If X wasn't global, then this wouldn't even make sense, right? Because here you're saying X is equal to something that involves X, and we haven't defined X before. So that implies that the X must be global. It must be something that exists outside the function random. So, okay, so that's like that. And this kind of is enough. Now, if you're using the random numbers for like some kind of security thing, like for example, you're generating some kind of passcode or something. So for example, you know, you're generating kind of whatever you get on your cell phone when you do two-factor authentication sometimes, then this is probably not enough. Because if you're really determined and you're a hacker who figured out that, oh, like actually what they're doing is not really generating random codes, they're just taking the current time and generating a random code based on the current time, then they can in principle try to infer what the code will be based on what time it is. Make sense? So that's bad. And for that reason, sometimes when you generate the seed, if people are really security minded, what they're going to have you do is like actually do something physically with the computer. So kind of like move the cursor around or something and get the seed based on how you move the cursor around, like based on like the minute movements that you have. That's kind of a genuinely random process, or at least kind of as random as it gets, because it's like you deciding how to move the cursor around. There's also like physical devices you can use to get like randomness or like supposed randomness. Of course, there's like a philosophical issue of like, well, maybe everything in the universe is predetermined anyway. And in that case, nothing is really random. But but that's not the big security concern. Or if it is a security concern, then it doesn't matter because it was predetermined that you're going to get hacked anyway. The universe is already set up that way. So that's right. So, okay. So back to more earthly concerns. Let's say that I want to use this the way I use random.random. So what I might do is I might save the file as So I'll save the file as myrandom.py. And then if I want to use it in a different file, what I'll do is I'll say import myrandom. So what I'll do is I run it once so that I'm in the same folder. I'll comment this out because otherwise it's going to run every time I import. So I don't want that. So I also need an initialize here, right? Because if I just import this, X at first is not defined at all unless I run seed. Right, so seed says what the X is, but random.random works without you setting the seed. It has some kind of default seed. So what I might do is I might say I have a function. I'll name it initialize. Doesn't have to be named initialize, but I can name it initialize. And here I'll just say kind of import time seed and time.time. And that's enough. Now, what I need to do is I need to also call the function initialize outside of a main block. Here, I don't even have a main block. So the idea would be when I import just means run all of it. So that means including running initialize open parentheses, close parentheses, which means that I'll run initialize. And initialize will set the seed based on time.time. Make sense? So I'll save this, and then I'll use the function over here. It's my thing. What? Oh, no. X. Okay, I think I'm good. So here I'm saying import myrandom. So I'll make sure that it's in the same folder. It's apparently not. So the folder is over here. So I'll say import myrandom, and then in here I can have a main block if I want. And I'll just print myrandom.random like so. And I can run it. And here you can see that I can get a different random number every time. So that's great. If I want to, I can set the seed and make it so that I get the same sequence of random numbers every time. So I'll say myrandom.seed. Whatever, 5. And then every time I run this, now I get the same supposedly random number. If I do it twice, I get 2 random numbers in the sequence. I can, of course, reset the seed anytime I want. So what will I get if I run something like this? Anyone? So what's the output here? Yeah.
The first and second rates, so we did great, but the third one will be the same.
Exactly. Yeah. So after I set the seed to whatever, I always get the same thing. That's what we saw before. And then the next thing is determined on the X from the previous one. And then I just set the seed again. So I'll just get the first number again. So it's going to be 0.23, 0.73, and 0.23 back again. And that's going to be like that every time forever. All right, questions about it? All right, and here kind of the important thing to note is I just made the file myrandom, and then I said myrandom.random, right? So the naming here is arbitrary. I just decided to name this function, this module rather, myrandom, and inside it I'm accessing .random, which is my name for this function. All right. So the technique here is known as keeping track of state. This is something that you've done for project 1 anyway. So, and the state in this case is X, right? So X is kind of the state of the program, which says like, this is where we are. We can figure out what to do next. The next time we call random in the same way that you keep track of like the current time, current heathens, whatever, and then say, next time I call whatever, offer star or perform activity, I'll just update all the global variables. And this is a situation that, again, with our tools, what makes sense is using a global variable. So I want to do another kind of security related example that uses the same technique. So let's say that I want like a password manager. Actually, like someone approached me at the beginning of the lecture with the same problem where they kind of requested to change their password on Piazza one too many times and got locked out of Piazza forever. So I kind of want to make a script, hi, wherever you are. So we'll fix it. Alpha 11. Okay. So that's what we want to do. So I want to make a function like this, and that's going to be like username, password. And I want it to basically return true if username matches password. And I want it to, unless user is locked out. And I want to say user is locked out if they try to log in 3 times in a row unsuccessfully. Make sense? So we first need to decide how we store the passwords, right? And the tool that we have right now is lists. So I can say like usernames. So our usernames are going to be Cluet and Davis and me too, like this. And then we'll have the passwords. So I know matrix probably, and probably rigorous. And this is my password. Not really. And the way, so this is really Stangaby, isn't it? So, okay. So the way it works, right, is username at I matches passwords at I. So this is not the best thing that you can do in terms of design, but that's the best thing to do with tools that we have. All right. So, okay. So eventually we want to do login. I think for now, we just want to do a function that verifies that the username actually matches the password, right? So this is going to be username, and it's going to be password, and this is going to be usernames, and this is going to be passwords. So basically, how do we figure this out? Well, if we have a username, we can look up the location of the username. If we know the location of the username, then we can check, well, is the password that matches that in passwords the same as the given password, right? So the way, if you remember that I can get the location is I can say usernames dot index, and then, for example, me is 2. So that's the location of, if there is repeats, that's a problem, but we assume that this is well formed. So that's just going to be like this. So that, for example, is going to be 0 because Professor Cluet is in position 0 there. Right? So, okay. So we can say actual password. is passwords at the location where the username is, right? So we want to look, for example, for Clut, we want to look at passwords at 0. So I'm going to say usernames index username. Index. Does that make sense? Questions? So now we have actual password. So now, does it match the password? Well, if password is equal to actual password, then yes. If not, then no. So I can just say return password equals actual password. So if this is true, so if password is equal to actual password, we return true. If it's false, we return false. So don't need an if statement there, because the value of password equals to actual password is either true or false. And if it's true, we need to return true. If it's false, we need to return false. So just return this. Does that make sense? Questions? All right. Technical Q&A. Okay, so I would again ask kind of, I'm looking at technical Q&A, so I'm asking that this is just actual Q&A, because otherwise I hear the chime and apparently it wasn't. So just ask on the answer or answer after lecture. Like, it's not a problem that you ask, but please keep the technical Q&A to like the lecture. So, okay. So my screen sharing is paused. Why is that? I am screen sharing now. So, okay. So that's done. So now for login, kind of the most naive version. So I'll move this up just because by convention, it's not actually necessary in Python, but by convention, if you use a function, then it should be above the function that's being used. You can't always keep to that actually. So the naive version is to say, well, like if username matches password, then return true. So here I'm doing something that I kind of advised against, where I say like, if this return true, else return false, I could have just said return that, but I need to actually tweak it, right? So if the username matches the password, I don't necessarily return true, because it might be that I'm locked out and I need to return false. And it also might be that I need to make it so that things are locked out. So I'll make a variable. It has to be global, because it has to be that across different hosts to log in, I actually keep returning true or false. So here, if the username does not match the password, then I might need to log out. It also might be that I'm already logged out. So here I'll say if username matches password and I'm not locked out, then I don't need to return, then I really need to return true. On the other hand, here, it might be that I need to be locked out, right? How do I know that I need to be locked out? Well, I need to know that I tried to log in incorrectly 3 times in a row. Right? So here I might ask, okay, so how many times did Gerjoy try to log in a row unsuccessfully? Well, that means I need to keep track of that as well. So I'll do global login attempts. And initially it's going to be all zeros. So here, what I'm going to say is, have 1 minute. So what I'm going to say is, okay, not a successful login attempt. So that means that I need to look up whoever is trying to log in and increase their count for login attempts. Right? So what I'm going to say is if the username is in username, so if it's a correct username, then I'm going to look up at where that person is. And I'm going to increase the count by 1. Next time we're going to do the log out. I will see you on Friday. Bye. Thank you.